In this video, we're going to be doing a collisions practice for Unit 3, Work, Energy, and Power. So, a 2.0 kilogram car moving at 4.0 meters per second elastically collides with a 1.0 kilogram car initially at rest. What is the final velocity of the 2.0 kilogram car? The 1.0 kilogram car is at rest. So, our first course of action is we need to use the elastic collision formula. So M1 is 2, M2 is 1. The sum times 4.0 plus 2 times 1 times divided by 3 times 0. This expanded is 2 is 1 plus so if you plug that in your calculator, this is 1.33 meters per second. A 0.5 kilogram ball moving at 10 meters per second strikes a ball and rebounds at 8 meters per second. We want delta K. So kinetic energy is this general form. Now you do it for both final and initial. So this is equal to 16 joules. Now you have to find the change in this. The change is going to be 16 minus 25, which is negative 9 joules. Two objects collide and stick together. What quantity is conserved during the collision? If they collide and stick, they have a perfectly inelastic collision. So this means that you have momentum always conserved, and also your kinetic energy is not going to be conserved. So your answer is only momentum is conserved. A 3.0 kilogram object moving at 5 meters per second collides inelastically with a 2.0 kilogram object at rest. So this is 3 kilograms, this is 2 kilograms. What is the final velocity when they become one mass? Because they're inelastically bound, they're bounded now. So you have to use conservation of momentum, which is that P initial is equal to your final. So you have to do your P of your object 1 plus your object 2 is equal to your object 1 plus your object 2. You would write MV plus MV is equal to MV plus MV initial. You could say 1 initial, or we'll just say initial on this side. We don't need to do that. So you can rewrite this as m1 plus m2 vf. You can factor out that vf. So v1f is equal to v2f because it's going to be one object, and when you have one object, it can only move in one direction at once because it's just one object. It can't be moving at two different velocities. You just plug in everything now, so your answer would be B. A 1 kilogram object moving at 6 meters per second collides elastically with a 1 kilogram object that is at rest. What happens after the collision? When you have elastic collisions with the same mass, which we do here, m1 is equal to m2. The objects are going to exchange velocity, so they just swap. So that means that our first object is going to stop. And our second object will move 6 meters per second. This is your initial state. And then your final is going to be reverse of this. So this is m1. Now m1 is going to have a velocity of 0, and then your m2 is going to have a velocity, we'll label this final and this is initial, equal to 6.0 meters per second. So they swapped. Your answer is C. In a perfectly inelastic collision, which statement is true? Perfectly inelastic, your objects are going to stick and your maximum kinetic energy is going to be lost. So you have your conservation laws. So your delta P is always conserved, aka sum of P initial is equal to your sum of P final, and your kinetic energy is not conserved. So your kinetic energy final is always going to be less than your kinetic energy initial. Your answer is B. A 4 kilogram object moves at 3 meters per second and collides with a 2 kilogram object moving in the opposite direction at 10 meters per second. If they stick together, what is their final velocity? And then this object is going to be moving at a velocity that is in the opposite direction at 1 meters per second. We can use conservation of momentum because all collisions have conservation of momentum. So if they stick together, it's inelastic. So you add their masses and you factor out your velocity. So Your answer is going to be approximately 1.7. A collision is elastic. Which statement is true? So when you have an elastic collision, like we said up there, is your momentum is going to be conserved and your kinetic energy is going to be conserved. Oh wait, actually earlier we had inelastic, but this is for elastic. So the difference is your momentum is still conserved as well, but here your kinetic energy is also conserved. So your answer is just D. A 2 kilogram object moving at 5 meters per second collides with a 3 kilogram object at rest. If the collision is perfectly inelastic, what fraction of initial kinetic energy is lost? So you can calculate your initial kinetic energy. It's 25 joules you had initially. Here we know that we're looking at the kinetic energy of your mass 1 because we know that the kinetic energy of your second mass was 0 because 1/2 times mass times 0 is 0. So now we can use our conservation Your answer is going to be 10 times VF, which is equal to 2.0 meters per second. So now you can find your final kinetic energy. So you have an inelastic collision, so that means that you have to sum the masses. So now you have 10 joules. Now you find your delta K, kinetic energy, 1/2 5 times 2.0 squared. No, what am I doing? I mean like 25, which is your final, minus your initial, so that's going to be 15 joules. That is the change. So now we have to find the fraction loss. So 15 joules equals your lost, and then your total, or what is it, your final? No, your initial. So that's going to be 15 joules over 25 joules. Now that's going to be equal to 0.60, and as a percent, that would be 60%. So that's going to be C. Two objects collide in one dimension. After the collision, one object has more kinetic energy than before. What must be true? Well, if you have a closed system, that means that total E is going to be conserved, and kinetic energy can't increase unless energy is added, unless you add energy. So that means that if kinetic energy increases, that means external work was done.